Okay, let's see how does a decision tree split on continuous features. So continuous in the sense all the values in these kind of features belongs to a real number set R. There are some variants of decision trees which allows us to make the multi-way splits. But in this video, I'm only assuming the binary splits or the binary decision trees. So the step one is to sort the feature by values. Step two, for each of these values, make a split and compute the weighted average impurity in case of classification or compute the sum of squared errors in case of regression. So after computing, these metrics for every split, we select the split which has the least of this value, either the weighted average impurity or the sum of squared errors. So to keep these things clear, let's look into an example. So I'm considering a continuous feature f, which contains only 4 values. If you look at the values in this feature, so all these values in the feature are continuous. So the step one is to sort the values in this feature. So once you sort the values in this feature, so you get a new list of values which are sorted. If you look at the values, all these are sorted. So I'm calling this as fs. Okay. So now let's try to understand how do we split the feature in case of classification. So in order to understand that, I'm assigning a class label for every value in this feature. So I'm assuming a binary classification problem. So I'm assigning either 0 or 1 to every value in this feature. Okay. So now, like we mentioned above, the step 2, for each value, we make a split and compute these metrics. So how many values do we have here? So we have 4 different values. So we make 4 different splits. So how does the split looks like? So the first split is fs less than or equal to 1.4. And second split, fs less than or equal to 2.3. Third split, fs less than or equal to 5.6. Fourth split, fs less than or equal to 8.2. Now, we need to compute the weighted average impurity for every split. For all these 4 splits, we need to compute the weighted average impurity and select the one with the least impurity measure. Okay. So here, let's consider the first split, which says fs less than or equal to 1.4. So when you split the data at this point, you'll get 2 different lists. List 1, which has a class label of 0. List 2, which has the class label of 0, 1, and 0. That is, we are saying feature less than or equal to 1.4. That is up to here. So you consider only this specific part, okay? And you consider the remaining part as the other split, okay? So now we need to compute the weighted average impurity, okay? So how do we compute that? First, let's understand what are the weights here. So the weights are nothing but the probability of the samples. So in the split 1, it only has a single sample. In split 2, it only have 3 samples. But the total number of samples are 1 plus 3, 4 samples. So the weight for list 1 will be 1 by 4. Okay. And the weight for list 2 will be 3 by 4. Okay. So these are the weights. Now let's calculate the impurity for list 1 and impurity for list 2. In the classification setting, there are different measures to find the impurity. In this example, I'm computing the Gini impurity. So the Gini impurity is calculated as 1 minus probability of class 0 in this list whole square minus probability of class 1 in this list whole square. So this is the formula for that. Similarly, we can compute the Gini impurity for list 2. 1 minus probability for class 0. That is, how many points we have? 2 zeros. How many total points we have? 3 points. That is 2 by 3 whole square. Similarly, probability for class 1 whole square. For class 1, it's 1 point. The total points are 3 points. So it's 1 by 3 whole square. So when you break down this, you'll get 0.33 as the metric, as the value. Similarly, we compute the weighted average impurity for all these conditions. For feature less than or equal to 2.3, for feature less than or equal to 5.6, and for feature less than or equal to 8.2. Now I have computed these already. So when you look at all these four numbers, so the third step is to, select the split which has the least weighted average impurity. That's why I'm selecting this specific split, because if you compare all these four values, this is the split. That is, feature less than or equal to 2.3 is the split with the least weighted average impurity. Okay. So now we select this as the condition. Okay. So this is in case of the classification. Now let's try to understand how it works in case of regression. So instead of assigning the class labels for every sample in this feature fs, now I'll assign a regression variable. That is, I'll assign a continuous variable for every sample. That is for all the points in this specific list. Okay. So here I have assigned, a continuous value for every value in a feature fs. So again, the splits are same here. Again, we have the same four splits. Feature less than or equal to 1.4, less than or equal to 2.3, less than or equal to 5.6, and less than or equal to 8.2. In case of classification, we have computed the weighted average impurity. But in case of regression, we need to compute the squared errors. Okay. So let's see how can we compute the squared errors. So again, so when we split this feature with the value 1.4, again, you get two different lists, first list and second list. In list one, you have only one value. So how do we compute the sum of squared errors? It's actual value minus mean of those values. Actual value is 1.2 and mean of this list is also 1.2 because this list only have a single point. So 1.2 minus 1.2 whole square. Okay. So this is the squared error for this specific list. Similarly, we can compute the squared error for this list also. So initially, we need to take the mean of these three values, okay. So the mean of these three values is equivalent to 4.93. Now we compute the squared errors, that is 4.3 minus 4.93 whole square plus 4.2 minus 4.93 whole square plus 6.3 minus 4.93 whole square. So we get the squared errors for every point. We just take the sum of all those errors. Either we can take the sum of squared errors or we can also take the mean squared errors. In this case, I'm only considering the sum of squared errors. So for this split, the sum of squared errors is 2.8. Similarly, I have computed the sum of squared errors for every split. So if you observe the values here, so I have computed the sum of squared errors for every split. Now, coming to the third step, we just need to select the split with the least error. That is this specific split. Feature less than or equal to 1.4 is the split with the least sum of squared errors, that is 2.8. So in this case, we select this specific split in case of regression. Okay. So this is how we compute, this is how a decision tree splits the continuous feature. Just to give you the summary, so these are the main three steps. Initially, we sort the feature by values. Then for each value, we make a split and then compute either the weighted average impurity in case of classification or the sum of squared errors in case of regression. So once we compute these metrics for every split, we select the split with the least weighted average impurity or sum of squared errors. Okay. Thank you.